Day 8.5, we're going to look at sigma or summation notation and also series. For the warm-up, can you determine which sequence is arithmetic or geometric? Can you write a recursive formula? And then from yesterday we looked at an explicit formula. Can you write an explicit formula? So again, to figure out if it's arithmetic or geometric, you can take one term and either subtract the term before it or divide by the term before it. And if you get the same thing every time, that will tell you if it's arithmetic or geometric. So let's try arithmetic first. If you take a look at the first one, we have 48 minus 50, and we get negative 2. Let's try that again. Let's do 46 minus 48. We get negative 2 for any two terms that we pick. If we subtract the one before it, we get negative 2. So what happens, or what that means, is we have a common difference right here. We're subtracting 2 every time to get to the next term. And if you're adding or subtracting, that would be an arithmetic sequence. To write the recursive formula, we need the starting value of the first term, the first number in our list of numbers, and that would be 50 in this sequence. And to find any term, you would take the term before it, and you would subtract 2. So there's the recursive formula. Again, you need the starting value, the first number in the list, and then what's the pattern, what's happening every time. What do you do with the previous term to get to the next term? The explicit formula, if it's arithmetic, will be, it's linear, so y equals mx plus b. In this case, our slope is negative 2, and our y-intercept would be if there was a term 0. So we're going to go backwards. Instead of subtracting 2, we'll add 2. So the 0 term would be not 50, but 52. So our y-intercept would be 52. So there's an explicit formula which we can use to figure out any term by plugging in for x, for the term number. Okay, let's take a look at sequence B. Again, arithmetic or geometric, you could take any term and subtract the one before it. So if we do that, we get negative 12. We could take 64 minus 16. Does that give us negative 12? And that doesn't. So we'll try and see if it's geometric. So if it's geometric, we take any term, divide by the term before it. Nope, 16. And you can see that here, this one is geometric because we're getting a common ratio of 4. So what that means is to find the next term, we're multiplying by not 2, but 4 every time. Okay, the recursive formula, again, like for an arithmetic sequence, we need the first term. So here it's 4. To find any term, you take the term before it. And this time we're multiplying by 4. You can use a times, you can use a dot. I like to use the parentheses. The explicit formula, it's exponential, so it's multiplying by a number every time. So we have a times b to the x. We do need the starting value, though, which again would be the 0 term, like the y-intercept. So we do have to go backwards one. So instead of multiplying by 4, we divide by 4. So our starting value is 1. So here, our equation will be y equals 1. And we're quadrupling it every time to the x power. Okay, so the next part of this unit will focus on adding up terms of a sequence. And so that does have a name. It's a series. A series is when you add terms of a sequence, when you're adding up lists of numbers. A sequence. And if you recall, a sequence is your ordered list of numbers. So your sequence is your list of numbers, has some kind of pattern, adding or subtracting. A series is when you add up terms of a sequence. They will start with an S. A sequence is your list. The series is the sum, if that helps you remember it. So sequence is your list, and a series is when you add them up. You find the sum. So what if I said add up the first 6 terms of sequence A? There is a shortcut way to write this statement, and it's using sigma notation. So sigma is this funny looking E symbol, a Greek symbol, and it means add them up. So add them up is that sigma. And to say the first 6 terms, we're going to say, all right, let's start with the first term, and let's go all the way up to adding the 6 terms. And then you have to tell me what sequence to use. So again, I should put arrows. So again, here, this means add up. And then if we want for sequence A, we're going to write the explicit rule. So there's the explicit rule, -2, and I should make this an n, plus 52. So again, this just means add them up. It's the shorthand way of saying add up the first 6 terms of this list of numbers, which you would get by using this rule right here. Okay, so that's what sigma notation looks like. Here's the anatomy of sigma notation. So you can see that we said, all right, where to start at? We said start at the first term. So there's the bottom right here. Here's the 1 on the bottom. Start at the first term. Go to the 6th term, so the ending terms on the top right here. You put the explicit formula right here. And again, if it's arithmetic, it's linear. And if it's geometric, it's exponential. And again, we've been starting at the 0 term. If you start at the first term, and we'll talk about this, if a sub 1 is your first term, you have to go backwards 1. So n minus 1 would be this right here. So we'll take a look at that as well. Okay, so today our goal is, can we use what we did yesterday, and can we find the explicit formula? And then can we write an expression that would mean add up some of these terms? So this is summation or sigma notation. It means add them up. Okay, so how do we do it? Let's say we wanted to say add up all the terms of this sequence right here, which is arithmetic. So first let's figure out the explicit equation. So we have y equals mx plus b. So we need 2 things, slope and y-intercept. So here the slope is, what is it increasing by every time? We can see that it's 3. And so that would go next to the x, or n, and we'll put it as an n in our sigma notation. And then we need the y-intercept, which would mean, like, what's the 0 term? And we have the first term as 2, so the 0 term, instead of adding 3, we'll subtract 3. So 2 minus 3 is -1. So there's the explicit. All right, let's put it in sigma notation, and let's say add them all up. So let's start at the first term, which is 2. I'm going to write our term. So here's the first term, second term, third term, 4th, 5th, 6th. So here we have 7 terms. So to say add up all 7 terms, we're going to say start at the first term, n equals 1, go to the 7th, and use the rule 3n minus 1, which means you're just plugging in a 1 here to get the first term, a 2 here to get the second term, a 3 here to get the third term, and so on. Okay, so that is the explicit notation that would tell you or add up the first 7 terms of this sequence. Let's do another arithmetic one. So again, let's put it in the form y equals mx plus b. Okay, so again, we need 2 things, slope and y-intercept. It looks like here we're adding 7 each time. So we have y equals 7x. The y-intercept, instead of adding 7, we're going to go backwards 7. So -6 minus 7 would be -13. So there's your explicit. Let's write the sigma notation. Start at the first term and go to, and we don't know what the 71st term is, so we got to figure that out. Again, this is the first term, second term, third term, 4th term, but there's that ... So we got to figure that guy out. And so to do that, all we do is plug in a 71 for y. And then we can solve. So let's figure out what term we have, or the x value. So we'll add 13 to each side. So we get 84 equals 7x. Sorry, that's messy. We'll divide each side by 7. Okay, so x, or n, is 12. This is the 12th term. So let's add up all 12 terms using this rule, 7n minus 13. There's the explicit equation. All right, let's take a look at how you would write it geometrically. So right here, again, what's the common ratio here? To find the ratio, we take any number, divide by the one before it. So here the ratio is 1/2. So the explicit form, let's start at the first term. Here's 1, 2, 3, 4, 5 terms. The starting value, we would go backwards 1. So instead of dividing by 2, we would multiply by 2, and the starting term would be 16. We're taking half of it every time. The other way to write this, let's say you wanted to start, Okay, so let's say you wanted to say that, all right, 8 is the starting value, and we know it's 1/2. Well, we have to push that back. So here, we have to push that back by saying, all right, shift your sequence to the right 1. So that's how we get that right here. Oops. Okay. All right, so two ways to write this. You can either start at 16 and start at n, or if you want to start at the first term, then you have to push it back or explain in your equation that you did start at the first term, so n minus 1. Okay, so let's take a look at our last one. Again, we'll write it up two ways. Let's find the ratio first. The ratio, we take any number, divide by the number before it. So here our ratio is 2. All right, again, we need to figure out what term we have, so we don't know that, but we can write the equation. So this one, if we go backwards, one will divide by 2, so this is 1.5, and we're doubling it every time. Okay, so there's one way to write it, or we could say, excuse me, start the first term. Let's say we wanted 3 here, but then we have to push it back, n minus 1 right here. So each of these equations will give us the same answer. All right, so let's use it to find 192. I'll just use the first one. Okay, so 192 equals 1.5 I need more room here. So 192 equals 1.5 times 2 to the n. We'll divide each side by 1.5, and we're going to log it. 192 divided by 1.5. We get 128 equals 2 to the n. Log base 2 of 128 equals n. Oops. All right, so log base 2 of 128. And so that's the 7th term, so n equals 7. So the 7 would go right here, or it would go right here. Okay. So now let's take a look at 3 more, which means can you write this out? So it says write the following as a sum of terms and then find the sum. So this is saying add up the first 5 terms using this rule. So we need the first 5 terms. So we need to find the first term, which means just plug in a 1 for n. We're going to find the second term, which means plug in a 2 for n. We'll find the third term, which means plug in a 3 for n, and so on. And if we do this, 3 minus 1 is 2, 6 minus 1 is 5, 9 minus 1 is 8. You can see, and you should know that, hey, we're just adding 3 every time because the slope is 3 right there. So to figure out a sub 4, I can just add 3. So that would be 11, and a sub 5 would be 14. So we're just adding 3 every time. Now we can add them up. So to add them up, we would say, all right, let's add up 2 plus 5 plus 8 plus 11 plus 14. So I'll do that really quick. 2 plus 8 plus 11 plus 14. And we would say the sum is 40. Okay, so that's how you can actually use sigma notation to add these things up. Let's do the next one. This is, number 2 is saying, all right, add them up. And the rule is just n. And this one starts at the 4th term and goes to the 7th. So the 4th term is just 4. The 5th term is just 5, because you can see it's just n right here. The 6th term is 6, and the 7th term is 7. So we're going to add up 4 plus 5 plus 6 plus 7. And we'll get 22. So here the sum is 22. Okay. In our last one, we can see that this is geometric. The number's doubling every time. This one starts at the first term, which is 3. And again, we want 4 terms right here. So the first term, just plug in a 1. 1 minus 1 is 0. Anything to the 0 power is 1, so this is 3. The second term is 3 times 2 to the 2 minus 1. 2 minus 1 is 1. 2 to the first power is 2. 2 times 3 is 6. The third term is 3. We're going to double it to the 3 minus 1. 3 minus 1 is 2. 2 squared is 4. And then 4 times 3 is 12. Or you know the rule here, hey, this starts at 3 and it's doubling every time. So to find the 4th term, we can just double the 24 and get 12. So we can add up 3 plus 6 plus 12 plus 24. And so we would say the sum here is 45. All right, so our goal today is to get comfortable with this sigma or summation notation. You have to understand what it's asking you to do and also how to set it up and to use it. So you have some practice problems right here.